Today we need to talk about a concept known as direct variation. And direct variation is just a specific kind of linear equation. Very specifically, it is a linear equation where the y-intercept is 0. So anything that's an example of direct variation will always involve the equation y equals mx. There is no y-intercept. Now, most textbooks don't use slope-intercept form when they're talking about this specific thing. They'll, like your textbook uses something, they call it y equals ax for direct variation. And it's really nothing they can get concerned about. It's more of a context thing. Like, you guys each call your parents mom and dad, but it would be weird for me to call your parents mom and dad. Like, I'll call them Mr. and Mrs. So-and-so. And their friends might call them by their first name, right? Context determines what it is you're talking about. So when you see in your textbook y equals ax, it's really the same thing as y equals mx. In the context of direct variation, the slope is also called the constant of variation. Right. We've seen it as the slope before, but in this context it happens to be called the constant of variation. The last thing that's true about all things that are examples of direct variation is that if you were to take the values, the quotient of x and y is constant. That means if you have some x and y values, their quotient, or if you were to take x and divide it by y, or take y and divide it by x, you'll always get some number. And that number is always the constant of variation, or slope. Some phrasing that'll come up are things like varies directly. If you see this, you should immediately be thinking y equals mx, or y equals kx, or whatever the case may be. Right? This is the phrasing that clues you in. Or if you see vary directly, x and y vary directly. Again, also always clue phrasing for what's going on. Now, the first example that we'll need to deal with is example 1 in your books. If you want to follow along, it's on page 107. But we need to write and graph a direct variation equation that has negative 4, 8 as a solution. Well, since we're told it's going to be a direct variation, what we know is that we're going to be using the equation y equals, your book uses ax, and we're told specifically that a is y and x is negative 4. And so hopefully you can see that we're now it's very easy for us to solve for a. If we divide both sides by negative 4, we'll find that a equals negative 2. Right? This is the constant of variation. Once we know the constant of variation, we can have our equation. Y equals negative 2x. And from here, you've been graphing these for a long time. You know the y-intercept is 0. And since the slope is negative 2, you go down 2 and to the right 1. And there's your equation. It's direct variation because it goes through the origin. We found the slope. We're done. Why don't you try to do a similar problem on your own? We want to write and graph a direct variation equation that has negative 3, negative 9 as the solution. Go ahead and try it. Well, if you've done it, if you pause this and done it on your own, since it's direct variation, you should immediately be thinking, alright, y equals ax, or y equals mx. And you know that y is negative 9 when x is negative 3. Dividing both sides by negative 3, we find that a is 3, which is the constant of variation. This means our equation is y equals 3x. And that's pretty easy to graph. The y-intercept is 0. We'll go up 3, to the right 1. There's our line, and we're done. So that gets you through example 1, section 2.5 on direct variation.